Tangent can be written as sine over cosine. Cosecant is 1 over sine. Secant is 1 over cosine. And cotangent is cosine over sine. See how sine and cosine are kind of like the things that just bring everything together? So it helps if we rewrite things using a sine and a cosine. Watch what happens in our first example. Our first example is to simplify sine times secant. So I'm going to rewrite this as sine of theta over 1 times, and what am I going to write instead of secant? 1 over cosine. As you multiply those two, you get sine on the top, and you get cosine on the bottom. Tangent. Sine divided by cosine is tangent. So tangent is the solution. Notice in the second example, cotangent times sine. What is cotangent in terms of sine and cosine?
Cosine divided by sine.
Cosine of theta divided by sine of theta. Sines cancel, leaving you with cosine of theta. In the next problem, I rewrite secant to be 1 over cosine of theta. And cosecant I rewrite as 1 over sine of theta. Notice in this situation, we can't just cross something out. And we did know that sine divided by cosine is tangent. But there's nothing on our sheet that says that sine times cosine is something special, does it? And in fact, there's no way that this becomes simplified. Not every trigonometric expression could just be reduced to something simple. So this was simplified from the beginning. I'm not going to give you that kind of a problem in a test where I try to trick you, say simplify, but it doesn't simplify. I just want you to see and understand that not everything will. You got to be a little intentional as you make up the problems. It's so nice of you to check on that. Yeah. All right, letter D, cotangent times secant. Cotangent is cosine over sine times, what do I write for secant? 1 over cosine. Notice that what happens? And I'm left with 1 over sine of theta. And Axel says 1 over sine is the same thing as cosecant of theta. Try letter E on your own. Try letter E on your own. So a little bit of snow last night here. Roads are pretty messy coming down. They should all be cleared up now. 7 inches up in my parents' town of Chaska. Everybody get secant? Awesome. We're kind of in the beginning stages right now. They will get more challenging. Notice in letter F, we have some negatives. So let's deal with those negatives right away. What happens to the negative for secant? Does it go away or does it move out front? Goes away. So I have secant of theta times, how about cosecant? Negative moves out front. And cotangent, the negative moves out front as well. So notice in our expression now, we now have 2 negatives that are out on the front. Those 2 negatives will cancel each other and make a positive. So it turns out in this situation that all the negatives go away. Okay. So I'm going to rewrite this in order to try to simplify it. Secant is 1 over cosine. Cosecant is 1 over sine. And cotangent is cosine over sine. Does everything cancel? Nope. The cosines do. And sine times sine is sine squared. So what do you think that simplifies to? The reciprocal of sine is? Not inverse sine, but cosecant. So this is cosecant squared. We have another problem in letter G that involves some negatives. Remember, the negative for tangent moves out front. And secant of a negative, that will disappear and just give me secant. What now? I'll rewrite tangent as sine over cosine. Do I put the negative with the sine or the cosine or with both?
So.
You can put it with sine or cosine, just got to put it with one of them. Cannot put it with both of them. So we have sine of theta, that is negative, divided by cosine of theta. And we're going to divide that by 1 over cosine of theta. Again, I don't divide these fractions. I multiply by the reciprocal. And the cosines go away, and I'm left with a negative sign. So we can also have them when they are dividing. Please try letter H on your own. Try letter H on your own. I notice that as I multiply by the reciprocal, the signs cancel. I get 1 over cosine, which should be secant of theta. Now, the truth is that none of the problems I give you on the test will be quite this simple. We need to progress towards ones that are a little bit more challenging. This is to get you used to a technique that we use. Just try and get you a little bit more familiarity. We're going to skip problem K, but we are going to do the others. Here we have sine of theta over 1 times secant would be 1 over cosine. And sometimes it's important to pause in your work and see if you notice something. For example, what am I going to end up with in the numerator? Tangent. And what do you have in the denominator? Tangent. And what is tangent divided by tangent? 1. So sometimes you can kind of look ahead a little bit and anticipate what's going to happen, what's going to move, and that can always be very helpful for people. Let's see if we can anticipate here. Here we have sine of theta over cosine of theta. And we are going to divide that by cosine of theta over 1 times 1 over sine. So do we have the same thing in the numerator that we have in the denominator, or are they different?
Reciprocal.
Yeah, they're reciprocals. They are not the same. So people might be tempted in this situation to cross everything out, but it won't work. Instead, what we will do is we will multiply by the reciprocal. And the reciprocal of that is going to be sine on the top and cosine on the bottom. So we get sine squared over cosine squared. What is sine squared over cosine squared? Tangent squared. We come to letter L. L is an exact problem I took from an ACT problem test. Raise your hand if you're taking the ACT this year. Okay, a lot of you will. Good for you. The ACT, it is just a score. Who's my senior here? Lily, where are you headed to college? Good for you. Okay, got in already, right? So the ACT score got you into the college you wanted to go to. Okay, and you will never have to think about the ACT again in any way, shape, or form. So don't make the ACT more about what it is than it really is. Okay, gets you to school you want to go to, maybe gets you some extra scholarships, things like that. But then you just set it aside. I will say last year we had a number of people on college trig. They scored 35s on the math part, 34s, very, 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 very high scores. And I would expect nothing short of that from many of you guys, your sharp group. But you are an advantage, juniors, having seen this stuff now compared to Lily. Was this available to you last year? Hannah, had you taken this course yet? No. So if you got to this part of the test, you just, it was just like guess at that point, right? There is not a single problem on the ACT which we will have not prepared for. Okay, so that you can be confident. So here I have tangent of x plus cosine of negative x. What is that? Cosine. It's just cosine. And then tangent of negative x minus tangent of x. And what do you notice happens? Tangents cancel, leaving you with cosine of x. Not that bad of a problem, right? But if you haven't seen it, then it's like, shoot, what do I do? That's the first step in trying to simplify trig expressions. We're going to try to do about 4 on this side, and we'll be done with the day. Again, this is not a 1-day deal. This is like a 3-4 day deal. The second step in trying to kind of simplify or work with trigonometric expressions is to use a substitution, okay? And this is probably next to changing a sine and cosine, the most common thing that we do. And this is definitely where you start to see more problems that will be like what you'd see on the test, okay? So as you look at letter M, it says 1 minus cosine squared times cosecant. And the fact is that a lot of people want to start this problem by distributing cosecant, and I'm going to say no bueno. You are not going to be happy if you try to do that. We need to find a different way, and you need to simply just recognize something. And the thing you need to recognize is this, we talked about it before, but we'll see if you remember. What is the capital of the United States? Washington, D.C. And what is sine squared plus cosine squared? Most important formula of all of trigonometry. Sine squared plus cosine squared is? 1. It is 1. Have to know that. So let's turn to that part of our notes so you can see what is logged in your memory that you just do not remember. And it is this stuff right here. As we look beyond 1, 2, 3, 4, we see this great formula right here. Sine squared plus cosine squared is 1. But it doesn't just take that shape. We can move it around. For example, suppose that I subtracted the cosine squared from each side. Minus cosine squared and minus cosine squared. I get a new formula, namely that sine squared of x is equal to 1 minus cosine squared. So that's another formula, isn't it? In fact, I wrote it over here for you, that sine squared is 1 minus cosine squared. And we could have done the same thing by subtracting a sine squared over the other side, and we would have gotten a cosine squared as 1 minus sine squared. It also just happens to be that this is the difference of 2 squares. So it's 1 minus cosine of x times 1 plus cosine of x, which I also wrote out here as well. You don't use all of them at once, but they come up from time to time. So when I am kind of faced with an example that looks like this problem, letter M here, I see a 1 and I see a squared, and that draws me to something that sits on that sheet. And what is 1 minus cosine squared? Sine squared. So all of a sudden, this problem turns to sine squared of theta times the cosecant of theta. Well, now that problem is identical to what we had on the first page. Let's change it in terms of sine and cosine. I have sine squared of theta over 1 times 1 over sine. And what's going to happen?
Get rid of the square.
Yeah, one of them goes away, right? One of the signs will reduce, and you'll be left with just sine of theta. So that thing reduces to just sine of theta. Notice in my next example, you have secant squared minus 1. Again, I have a squared and a 1. Look at that sheet of notes. Do you think that that's going to draw our attention to formula number 5, 6, or 7? Six. I see a secant squared and I see a 1. must have something to do with this right here, right? Let's look at it. Secant squared minus 1. What would we do to both sides in order to get a secant squared minus 1? You would subtract the 1. And what would you be left with on the left-hand side? So you can see it's sitting right there. Tangent squared is secant squared minus 1. So I'm going to go ahead and I'm going to grab that and plug that in. I see secant squared minus 1, and I put in its place tangent squared of theta. Now this becomes a problem just like we looked at on the last page. We write it as cosine squared of theta over 1 times sine squared of theta over cosine squared of theta. Notice that the cosine squareds cancel, and I'm left with sine squared of theta. It's okay if we're dividing as well. Our goal is to get through O and P right now, and then the bell will go. Secant squared minus 1, we can rewrite that as tangent squared of theta. And on the bottom, we write sine squared of theta. Now it's easy. You just got to make that recognition that there's a substitution that works in that place. So now we have sine squared of theta over cosine squared of theta, all over sine squared of theta over 1. What's going to happen as I multiply by the reciprocal? Yeah, I get sine squared of theta in the denominator, so notice that those sine squareds will cancel. And you'll get 1 over cosine squared. And what is 1 over cosine squared? Secant squared of theta. Okay, our final example for the day, and the last kind of technique that I want to talk about, and this is what we're going to pick up with tomorrow, is that sometimes what you need to do is you need to factor. So factoring is a third piece that we use in order to try to simplify expressions. As I try to draw your attention to this problem, people often get confused. I'm going to rewrite this problem instead of tangent squared minus tangent squared times sine squared. I'm going to rewrite it as 4 minus 4x so you can see the similarities between the two. If I have a problem like 4 minus 4x, can I just subtract those 4's? Like they're gone, and I'm just left with x? No, that's totally illegal. Everybody agreed? But if I factored that, I could rewrite that as 4 times 1 minus x. So now instead of a 4, I have a tangent squared, and instead of an x, I have a sine squared. What common factor can you take out of both of those? I take out the tangent squared. And what will remain?
1 minus sine squared of theta.
1 minus sine squared of theta. I now try to recognize what is the substitution that goes right there. Good. I see a 1 and a sine squared. That draws me to my formula sheet. 1 minus sine squared is cosine squared. And we don't want to be redundant. We have just simplified cosine squared times tangent squared. That was this problem right here. We do know that we come up with, in fact, sine squared. We don't have to redo it. That is our answer. So, what can you start on? You're not ready to complete the assignment, but you are ready to start. So if you would look at your homework cover sheet, it says there in the directions on the homework cover sheet, not on the assignment, but right in the homework cover sheet, it says do problems 1 through 6, 8 through 10, 13, 18, and 21. That those would be good ones to try first. Don't do all of them right away. There's a lot of them you don't know how to do. But try those first, and we'll come back tomorrow. Good job, everybody.